multiplication instead of drawing out that tree diagrams, because you're going to get some probability questions that have like 50 outcomes or more, okay? And I don't want to sit there and draw a tree diagram for 50 outcomes, okay? So we can use multiplication. And in example 1, we have find the total number of outcomes when a coin is tossed and a number cube is rolled. So right here we have our options for our coin, which our options for our coin are how many? Heads or tails, which is how many? 2. Okay, and then we multiplied it times our number cube, because from each of the coin options, heads or tails, I would have 6 options from each, right? 1, 2, 3, 4, 5, 6. And I would still have 6 from tails, right? 1, 2, 3, 4, 5, 6. So then instead of drawing that out, I could do 2 times my number of branches, which is 2 times 6. 2 times 6 is 12. So that gives me my total number of outcomes. If the question asks you to list the outcomes, do you think 12 is an acceptable answer?
Yes. No.
It said to list them. That means I want to know heads 1, heads 2, heads 3. If I say, what's the number of total outcomes, is 12 an acceptable answer?
Yes.
You bet, because I just want to know the number. Questions? Okay, when I ask you to list them out, I guarantee I'm not going to pick a question that has 45 outcomes. Okay. Example, so then here shows that tree diagram like I was talking about. I have 6 branches from heads, I have 6 branches from tails. Therefore, 2 times 6 is 12. Okay, got it A. Just because of time's sake, I'm going to go through it with you guys. Got it A. Find the total number of outcomes when choosing a bike helmets that come in 3 colors and 2 styles. Do I care what the colors are?
No.
No. Okay, so how many options do you have to pick from for the color, though?
3.
Times the number of times you, or the options you have to pick for styles.
2.
So 3 times 2 is?
6.
So you have 6, you have 6 outcomes, yes.
Wait, this wasn't. Is that as easy as this was going to be? Mm-hmm. I better not do my. Wait, I better not do my homework.
That's all it asks for, right? Okay, I am going to take it a step further, though.
Yeah, that's what
So the step further is going to be finding probability with that. So example 2 says find the number of outcomes from rolling a number cube with sides labeled 1 through 6 and a letter from the word numbers. So let's do that part first. So how many options do you have for your number cube or your dice?
1 through 6.
1 through 6, which is how many options?
6.
6. Okay, that's where they got this. Then they said times the number of options you have for letters in the word numbers. So you have 1, 2, 3, 4, 5, 6, 7 of them. And there's 7 different ones. Okay, there's no repeats in the word numbers, right?
Yeah.
Right? Okay, so just note that. So then 6 times 7 gives us
42.
So that's the total number of outcomes. So I answered the first question, but there's more than one. It says, then find the probability of rolling a 6 and choosing an N. So on your dice, we're going to kind of do the same thing for finding our numerator. So we have 42 total outcomes, right?
Yeah.
So over here for our numerator, how many options do you have for rolling a 6 on a dice?
1 through 6. 1. 6.
Landing on 6, right? 1.
Oh, yeah.
Times, how many options do you have for choosing an M? 1, right?
7.
So 1 times 1 is?
1.
1. So there's only one way that you could roll a 6 and pick an M. Therefore, there's 1 out of 42 ways, right? Which then we could take our numerator divided by our denominator.
And you would get 22.
We get 0 and 23,000. So Caden with a K, can you round that to the hundreds for me?
That'd be 300.
Good. Which is what percent, Caden with a C?
But this 3, doesn't the 3 tell the 2? Yeah.
Oh,
So
yes,
it'd be
sorry.
20 hundredths.
Oh, wait,
Or 2.
I thought that was an
It'd be
8.
2 hundredths.
Sorry, yes. Okay, do you want to correct your answer, Caden with K?
Yeah.
It would be what?
Just is 200.
200s, thank you for that correction. And then Caden with the C, what would be my percent? 2%. Okay, is that impossible?
No.
No.
That's a percent.
Is it unlikely though?
Yes.
Okay.
Highly.
Highly unlikely, very good.
It's not impossible.
It's not impossible, but it's not probably gonna happen. Okay? Kind of like it's unlikely you won't have homework, right?
It's likely we'll have
Okay.
no homework.
Example 3. Find the number of different genes available at the gene shop, then find the probability of randomly selecting a size 32 by 34 slim fit. Is this likely or unlikely that these genes would be chosen? Okay, so this actually asks us that question. So how many options do you have for your size?
5.
1, 2, 3, 4, and 5, right?
Yeah.
So 5. How many options do you have for the length?
3.
3, right? 1, 2, and 3. How many options do you have for style?
3.
1, 2, and 3. Okay, so 5 times 3 is?
15.
15.
Times 3 again is?
45.
So that's how many total options you have. But then we have to go through and find out what's the probability of selecting a specific one. So how many options do you have where the size is 32?
1.
How many options do you have where the size is 32?
0.
1, right? How many options do you have where the length is 34?
1.
1. How many options do you have where the style is slim fit?
1.
So 1 times 1 times 1 is?
1.
So I have 1 out of,
45.
which is the same as,
The last question, so 200 to 2.
oh, it's not the exact same. It was 40. It was over 42.
What?
So it's 0 and 22 thousandths. So Brooklyn, round that for me.
200.
Yep. So I would get. Okay, so I'm not done yet though, because then it asks me, is this likely or unlikely?
Unlikely.
It's unlikely, right? Because it's 2%. Not impossible, probably not gonna happen. 32s. So, it's like the 32 is like your length. So I'm a short person, and mine I can't work like 31's too long for me. So that's kind of longer to me anyway. The waist size though is about average. I don't know. The length is probably average too. I'm just short.
Same.
All right. Let's try be on your own.
So you would have to find what 2 dice equals, and they both go up to 6, so it'd be 12.
Okay, hold on. So my first dice, so this is dice 1. I have how many options?
6.
Okay. And then dice 2, I have how many options?
6.
So then what goes in between?
12.
Multiplying. 6 times 6 is
12. No. Oh, 36.
36.
I did it wrong.
Wait, but
Because remember that table that we do? Where we have like all that? Why did you use 12?
wait.
Because
I added.
because if you have a cube, there's 6 on each side, so all of them add together is 12. You pick 12 different things instead of there wouldn't be 36 options. There would be 5 options. If there's 6 sides on every dice.
Yeah.
2 dice.
You would end up having 36 total options, and I'll show you the chart because I have the chart saved to this, so I'll unplug my computer and I'll show you the chart and I'll show you. Okay, so is everyone okay though? You have 6 options on the first dice, you have 6 options on the second dice, therefore you have 36 total options,
Yeah.
and I'll show you that, I'll prove it to you. Okay, so then you have to figure out how many of them will get a sum of 12. How could you get a sum of 12? Using a dice.
6 plus 6.
6 plus 6. So how many options do you have to get a 6 and a 6?
1.
You have 1 option on the first dice to get a 6. Times you have 1 option on the second dice to get a 6, right? So 1 times 1 is out of, which is, I think you had a round, and it would have been 300ths, which is the same as 3%.
Oh, I got 17%, 17.
That's because you use 12 as your denominator.
Yeah.
And then how likely is this? Is this unlikely or likely?
Unlikely.
Unlikely.
Well, at least I got
I
the
was
unlikely
close.
part.
I had 1%.